Good morning, guys. And today our topic is AC fundamentals. Actually, we are going for series RLC and parallel RLC circuit, and that's why we have to know about AC fundamentals. You all know the what is the AC, but we have to know the how it is generated, how it is formed. Because in these courses throughout this BTech and after this BTech you have to deal with so many signals, so you have the sound idea regarding this. Okay, uh, that's why we're going to discuss. Look, first, how AC is generated. AC sine wave, you all know AC is generally deals with sine wave. Okay, but sometimes we can deal with the cos wave, because in Fourier series, whenever you go for Fourier series, there you can find some signal which is AC, just like AC sine wave and the cosine wave. Okay, so cosine is called cos. So first, from very basic, we are going to start. You know, this is the pole shoe, and this is total pole. And consider that is your rotor. Okay, one single rotor. Say this is your north pole, this is your south pole. How sine wave is generated? Say this is A and this color is B. Okay, okay. So when this rotor is rotating, in this direction. You can see this is A, this is the A, and this is the B. This is the total A conductor, A side and B side. You know, whenever it is rotated and coming to this position, just here some, please mute yourself. Look, here this is the flux. Here this is the flux. We are taking only few flux only for your better convenience. Okay. So whenever this A come to the, this is the A position, and this black terminal, it is coming the first this position. Sorry, don't put this. This is B. Okay. So this is coming only A to this is B, and this after then it is coming to this position, it is coming to the C. After then it is coming to the D, and then it is coming to the E.
¿Y de calla? ¿Su tala con esa guilda?
So it is rotating in A to B, B to C, C to D, D to E. You can find whenever A is there, I'm taking only one conductor. Okay. If this is armature, then we are considering this is only one terminal, one cut section. So A is coming here, and then it is coming to the B. Whenever A is this is a conductor is at the position of the A, then you can see no flux cutting is happening. So we put here is only 0. Whenever B is there, you can see if you just take a straight line, you can see some flux linkage are started to count cutting. Okay, so we can put some EMF voltage over this point. Whenever it is coming to the C, it is, you can see, if you take this, you can see after some time, this is the time, this is 0 time T1, that is T2. You can see here is some flux linkage are cutting, but this is the highest number. Okay, so again it is coming to the C to D position. You can see just like the B parallel, then it is coming, that is T3. This amount of EMF is induced. Again it is coming to the E. Again you can see there is again 0. So A, B, C, D, and this is E. And again it is coming in the point of E. So I am starting with the another color. Again it is rotating. So after rotating, it is coming to this position, that is F position. Okay, but in this terminal you can see the flux linkage are cutting the near of the south pole. Okay, if you, okay, so whenever it is cutting, so it is not positive, it will gives you the negative terminal. So if you draw this line, so after time 4, this is T5, and you can see here is the F position. Okay, again it is coming, and whenever it here, this is C position, this is G. Okay, so this point is G. EMF is induced over here. Again it is rotating, it is coming here, so it is coming H. So after this is T5, and this is T6, and this is T7. Sorry, this is T7, this is T8, GH, and after rotating again it is coming to the 0 position. This is T8 position, this is 0 position. So this is H, again A. So if you draw a line, draw this line, continuous line, because this is a continuous line, but we consider some specific point. That's why it is giving you the discrete point. But if you put the continuous line, just add this line, you can see it is giving you the sine wave. So you can see how sine wave is generated. If this is the EMF and this is the time, you can see a sine wave is generated over there. A sine wave is generated whenever it is going to the anti-clockwise this rotation. It is giving you this terminal. So this is the for this AC fundamental, we have to know how sine wave is generated. So from this alternator, it is already generated, and the frequency is depends on the rotation. And now we have to find out some signals. Though some signals are sine waves, but it may be DC or it may be AC. You all know this is the DC signal. Time, it is the amplitude. But just tell me, what is the which tell me the name of this signal. Is that a AC signal or is that a DC signal? Hello, anyone? Please tell me, is that a AC signal or is that a DC signal?
DC signal.
Yes, tell me.
All signals are DC.
All signals are DC.
Yes.
Okay, fine. Okay, thank you. This is the DC signal. So tell me, uh, which type of signals are there? Yeah, sir.
Sir, inverted signal.
Okay, this is look. This is converted signal. Which type of signal is this?
Digital, sir.
Digital. Okay, thank you. But it has some specific name. If this signal became here, if this signal is became here, then how could you tell that it's a digital? There is something, is another name. Say this is here. If you say this is 0, this is 2, this is 3, this is 5. Okay, so some signal is getting over here, some signal getting here, some you get some signal over here, you get something over here. So level is not the equal for all purpose. So how could you say this is, how could you nomenclature this signal? There is a specific name.
Sir, binary signal.
Binary means either 0, either 1 or 0, but it is not 0. Look, this is amplitude is something 2, something 1, something here. This is all are 5. You may give another signal also. There is a special name.
Discrete signal.
Yes, very good. This is called discrete signal, and this is called a continuous signal. All signals, all digital signals may not be a discrete, it may be continuous, okay, may be discrete. But if there is a only two levels, digital means two levels, 1 and 0, or something 5, or something a highest value and the 0, but you can see there is a level difference, but it is not continuous. So this is called a discrete signal, just remember. And this is AC signal, okay, but this is a square wave signal. So from this graph, how could I say which one is the AC, which one is the DC? Look, AC must have the magnitude in both sides, means positive side and negative side. But DC have the only the single side magnitude. Then this is called the DC. This is the main definition of this AC on DC signal. Look, AC signals means this is a bidirectional signals or alternating in nature, okay, but constant. Okay, this is the definition of the AC signal, or maybe variable. So from this graph you can understand, which one is the AC, which one is the DC, and which one is the discrete, depending on time. Okay, so next point is, so we get the conclusion from this graph. The both side have the magnitude, positive side and negative side. Then it is called the AC. AC means alternating. But what does it mean? The alternating. Alternating means it has the magnitudes in both sides, positive side as well as negative side. Then it is called the alternating, or you may say this is the AC. In both direction, positive and negative. Okay. So now coming to the point of amplitudes. It is the maximum So, what is amplitude? It is the maximum magnitude in positive and the negative of an changing signal or the time varying signal. Alternating means varying in the, it is also varying as per the time. So it is a time varying signal. It is so called peak value, or another name is there. Just tell me. peak value and another crest value. So sometime you get that is the peak value, sometime you get the crest value. So which one is the peak value from this here? Which one is the peak value?
Sir, C point.
C point.
C point.
Thank you, thank you. Or it is another name is crest value. So in so many questions you get this type of word. Now cycle. You all know this from your previous courses, but once again you have to recall this. Look, cycle. So from this point to this point, this is called one cycle. But if anyone asked you the definition, but how could you represent? So one cycle.
The time.
Yes, yes. Tell me.
Yes, sir. One complete means one complete AC current.
Yes, one complete AC, both in positive and negative. But how could you express this? One cycle is a
One complete
minimum
revolution.
complete revolution. Minimum span after which the waveform repeat one complete cycle means one cycle. This is one cycle is the minimum span after which it is repeat. The signal is repeating, but sometimes some modulation purpose. If this type of signal is coming, is that a one cycle? Is that a one cycle?
No, sir.
No, because it is not repeating. Sometimes this type of signals are created where for your modulation purpose, some communication signal communication system. So this is not your cycle. So cycle means a span, minimum span after which the waveform repeats. So as this is the BTech level, that's why so many exam, just like your gate, because gate is now it is very precious for you, because through this gate you can get job in PSU. Not only that, you get some mm, NIT, IITs for master courses, and in this master degree you can get also high amount of stipends also. So in these cases you can find this type of very basic questions are coming which are related to the basic concept. So we need to clear this concept very clearly. So this is a cycle. One cycle is the minimum span after which the waveform is repeat. So if there is this type of signals are given to you, you may say that yes, this is the same things is there, but this signals is not repeating. So this is, you can't say this is a signal, this is a cycle. Say, so which one is the cycle? Total is the cycle, but because look, you have to find out one cycle. You get puzzled. Okay, so some questions are coming in this way. So next we are going to the time period. Time period is the time required by a time varying quantity to complete a cycle. Okay. If so, tell me the time period. Tell me the time period of this signal. Say T1, T2, T3. What is the time period of this signal? Say 1 second, 2 second, 3 seconds. Anyone? Is there any time period?
Sir,
No.
cycle is not completed.
Yes, yes. Signal is not completed. Rather, you can say that is there is no cycle. Signal is not repeating, means not time varying. It abruptly. Okay. If I just stop here, this is abruptly. It is not changing. Is not time varying. So there is no cycle. Okay. Cycle is coming where it is coming to the AC signal. We can say this type. It may be, yes, you can find out. You can find out. So time period is the time required by an time varying quantity. Time varying quantity. Just remember this. So you may get puzzled after this type of signals. So it is second per cycle. So just brush up your previous knowledge. So time period is given for this type of signal, not this type of DC signal. And this is, the unit, the 1 by T. This is called frequency, and T is the second per cycle. This is time period. So time period is over here. Okay, say this is 1 second, this is 2 seconds. So time period is the 2 second, and the frequency is called or look, what is frequency? Frequency is the number of cycle per second. Number of cycle per second is called the frequency of the alternating quantity, or simply the cycle per second. So if there is a 1 second, you can find, so find out how many signals are there. This is the 1 second. Look, this is one cycle, this is two cycles, this is the three cycles, this is the four cycles, this is the five cycles, and this is the six cycles. So six cycles per second. So frequency is, so the frequency is six. Guys, just remember this type of example, because we can't remember this type of statements. Rather, we can remember this type of picture. Okay, so it is easy to remember this type of picture. What is the frequency? Number of cycles per second. So 1 second, this is the six cycles. This is frequency. What is this is the time period. There is any time period? No, we need any time varying quantity. So you have to remember these two examples, then we can clearly state this type of statement. So last one is phase.
Very good morning, everyone. We will start and internal
Phase for a phasors is
today's morning, the WhatsApp group. Whatever the instruction will be given to you, accordingly we will perform. So the examination will be conducted as per the university roll number. They are asking the students according to their roll number as per the university
is ours.
roll number. Student will.
Okay. So any angular difference is called phasors. Okay.
Sanman sir, are you there? Oh.
Just tell me, what is the phase difference here? What is the phase difference here?
Yes, sir.
Is there any phase difference?
No, sir.
Is there
No,
is
sir.
is there any phase difference?
Yes, sir.
Yes, sir.
Yes. Here is some phase difference. Angular deficiency is called the phase difference. So you know there is always a phase difference between a voltage and current for this AC. Where if you put some inductance, if you put some capacitance, but if you put only resistance, there is no phase difference. Okay, so this is very important for your RLC circuit. If you put any resistance, only resistive circuit, there is no phase difference. But if you put any inductance and capacitance, then it will, the voltage and current, if you voltage and current, there is some difference. But in this case, there is V and I. Okay, so this is the phase difference. It is given by omega equal to 2 pi f. This is the frequency. So it is angular plus time. It is rad unit, rad per second into second. So second is out. So it is given only radian. So it is called phi or omega, phi per omega. Okay. It is denoted as phi and omega. So guys, I am going to stop here. If you have any question regarding this topic, you may ask me. Okay guys, I am going to stop here. Thank you.
Thank you, sir.
You're welcome.